Hello, and welcome to Tomversations, a conversation with me, your host, Tom Hollingsworth, the networking nerd. Today, I'd like to talk about edge computing. It's a term you've probably heard used a lot recently, especially in reference to IoT. But you've probably been asking yourself, what is it, and why should I even care about it? Well, thankfully, I'm here to help you out. So let's have a Tomversation. Before we get into what edge computing is, we need to understand what it's supplanting. The old school methodology of computer use involved things like mainframes. And if you're old enough to remember using a mainframe, my heart goes out to you because, yeah, those things are fun. Essentially, you had one giant computer and everyone had dumb terminals that they used to access time on the computer. You logged in, you did your work, and you logged off. And if you were really lucky, you probably printed out your program on a bunch of punch cards. People realized that that was horribly inefficient for a couple of reasons. One, the mainframe had to do all of the work. And two, I have a terminal sitting in front of me. Why can't it do some of the work? As technology became more advanced and people started understanding how to build better, smaller computer systems, someone said, why not let the remote host do some of the processing power for us? And we collect data from a central host or serve that data. And you're right, that's why we ended up with something called client-server technology. And client-server is essentially the basis for all of the technology that we use today, whether it's on the internet or in the cloud. So you have remote hosts that have some processing capability fetching data from a larger server somewhere. And for the most part, it works. We have clients that fetch all kinds of data, whether it be text records or documents or even video. But what happens when the clients need to push data back the other direction? And that's where the internet explosion has really started to create issues. It's enough when all of the data sits in one central repository and all we're doing is pulling data from that location. Think about YouTube, for example. If all I'm doing is grabbing videos from people, then the thing works, right? But what happens if I have to push a whole bunch of data back? Think about real-time video, or security cameras, or autonomous vehicles. We'll come back to that in just a bit. These devices are pushing a significant amount of data back the other direction, which means they need a lot of bandwidth. Anyone who's ever tried to set up anything in the cloud knows that as expensive as it is to set up instances, it's just as expensive in order to be able to get the bandwidth to feed those instances. And with the explosion of new, faster technologies like Wi-Fi 6 and 6E and 5G, we now have client devices that can push a significant amount of data back toward the servers, and that overwhelms them. So think about what happens on something like, Black Friday, where you have a lot of people trying to connect to one server or a group of servers at one time. It doesn't work. And the reason for that is scale. Most places that build out their infrastructure build for regular scale or a little bit over regular scale. So if you're used to getting, 200 customers, you build for maybe 300, 400? Because you don't want to overbuild. You want to have that availability there just in case you need it. Well, what happens if you get more than you expect? What if you get, 2,000 customers, an order of magnitude bigger? Well, now you're out of resources and you're out of bandwidth for one thing. What happens if it scales even further than that? What if you get to 200,000 customers? Now you've got a real problem because no amount of scaling is going to be able to build out your infrastructure fast enough. And even if you have elastic resources on the back end, like you're using cloud, does your application scale large enough in order to use all of that? Odds are good it probably doesn't. Funny thing happens whenever you apply massive scale to simple things, you start finding problems you never knew existed because they exist more often at scale. Cloud can only solve the elastic resource problem. It can't solve the problem of what happens when you just push too much data. That's where edge computing comes in. So edge computing, as defined by companies like Gartner, is simply placing the compute resources closer to the edge where the users and the data live. Okay, that's probably the most simplistic definition you can imagine. Realistically, though, what does it mean? Well, remember when we decentralized the mainframes into clients and servers? Well, now we're pushing it a step further. We're disrupting the client-server technology by pushing compute resources even further to the edge. So instead of clients requesting data from servers, what we're actually ending up with is clients doing some of the processing on their own and then sending back summaries of that information. So think about something like an autonomous vehicle. You take an autonomous vehicle and it has a ton of data that it's sending. It's sending telemetry information. It's sending updates on autonomous vehicle setups. Even something that's not completely autonomous, like a Tesla that has a lot of radar data that it's sending back, or simply videos of what happens whenever it almost gets into a crash. That information has to go somewhere, right? Well, in today's paradigm, it's going directly to the cloud, which is great if you only have 30,000 Teslas on the road. But what happens if you have 3 million? Well, now you've got a huge problem. So what edge computing is trying to do is it's trying to place edge nodes as close to the data sources as possible to do processing of that data so that it doesn't all get sent back to the cloud. This is a huge driver in IoT. Well, why is that? Well, think about IoT devices. And before you point out your connected toaster or your thermostat, that's not what really IoT is designed to be. IoT is connecting other devices. Think about a hospital. Think about a manufacturing floor. Think about industrial IoT. These are devices that are not just sipping data from a cloud connection. They're pushing massive amounts of data back and forth. And the problem with autonomous vehicles and medical facilities and manufacturing floors is that a lot of times under regulation, they're not allowed to use cloud services, or it's cost prohibitive. Could you imagine your Amazon Web Services bill if you had to push 3 million vehicles worth of video and telemetry back and forth on a regular basis? Little nuts, right? Extend the metaphor even further, though. Think about something like real-time traffic updates. You want to send all that data to a central location to be crunched and then sent back? I don't think that that's going to work as well as you'd hoped. With edge computing, by having the resources that you need located closer to the users and the data instead of being centralized, it creates, in effect, a more peer-to-peer network. You remember peer-to-peer networking when you could just connect to other hosts and download things and you didn't have to go through a centralized server? Boy, that's really great whenever you have a lot of other things going on in the background, like real-time telemetry updates, real-time streaming traffic updates. You need to be able to aggregate data before you send it on. Now, the beauty of edge computing is you don't need a server everywhere, because with edge computing, every node on the edge is its own server, basically. It collects the data from people, and it sends that data back to the cloud for processing in some cases, but it doesn't always have to do that. Let's take something sufficiently advanced, like facial recognition, for example. You need a facial recognition algorithm to be able to process people, and that takes a lot of horsepower. So you're going to need something like the cloud or a very elastic resource. What if you only needed to identify people in a certain area? Maybe a town or a county. You could preload edge computing nodes with data about those people and reduce the processing load that's necessary. If you find somebody who's not recognized in the database, you could forward that along and have it processed and then sent back down. But by and large, you don't need 50 states or an entire world's worth of data in one central location. And you can distribute the processing across all of those edge nodes. So as someone moves from one location to the other, the information can be updated along the way. And if you're thinking this sounds an awful lot like the way that cell phone towers work, you're not wrong. We already have technologies that are capable of doing things like this edge computing because they have limited connectivity radii. So cell phones can't reach a tower that is 100 miles away. Mobile laptops cannot reach Wi-Fi access points that are, half a mile away. People have already been using discrete edge compute nodes without realizing it. And ironically enough, that's where a lot of the effort is going in to building out the edge. We're already seeing a lot of companies pick up and start deploying into the edge. Companies like Mobile Edge X and EdgeWorks are pioneering edge compute nodes that can run smaller versions of cloud applications locally for speed and then upload the data as needed to a central repository. EdgeWorks specifically has looked at something like delivery vans. don't need to be updated quite frequently. They need to know when people are scanning packages in and out. But by and large, we don't care about that data in complete real-time telemetry. However, if we get to a point where we want to know exactly where our package is at any one point in the day, all we have to do is install a mobile router into these devices that becomes an edge compute node, and we can stream real-time telemetry back to people who really want to know where that thing they just ordered is. And it goes even further from there, because once you have enabled edge compute nodes, you can start doing all kinds of things with them. So while you have startups like the ones that I just mentioned who are pioneering some of the edge computing space technologies, you also have larger companies that are starting to explore. A couple that have sprung to mind recently are Cisco and Aruba. Aruba, specifically at Aruba Atmosphere Digital, highlighted some of their new edge compute nodes, and I have a feeling we're going to see a lot more from them very soon on those technologies. That should just about do it for today's Tomversation. Thank you very much for joining us. I hope you learned a little bit about edge computing and you're excited to see where this technology is going to go in the future. If you'd like to follow along with more great conversations like this, including our Gestalt IT Checksum series and our on-premise IT Roundtable podcast, head over to gestaltit.com where you can find more great articles and media. And I can't wait to join you again for another Tomversation.